సో ఇందాక మనం చెప్పుకున్నట్టుగా ఇది ఇప్పుడు బెల్ సైకిల్ని ఇప్పుడు పీవీ డయాగ్రామ్ మీద చూపించినట్టయితే, సో ఇక్కడ ప్రాసెస్ 1 to 2 is the compression process, isentropic compression process. So here you can see the volume is reduced, but the main point is the pressure is increased to much higher level. So pressure P1 is somewhere here and it increases to P2. So pressure is increased very much. This is isentropic compression process. So in the compressor, the isentropic compression process is happening. So the next process in this cycle, in this Bell-Coleman cycle, is the constant pressure heat rejection. So that is here represented as 2 to 3. This is constant pressure heat rejection. Then again the next process in this cycle is isentropic expansion. So here in the expander, the isentropic air is expanded isentropically. So it is 3 to 4 is isentropic expansion. But here one small thing is, here before going to expansion, there is going to be some small suction stroke. That means the volume, the expander will take small volume of air from this. So this is the volume of air it is taking. It is a suction stroke, you can say suction stroke. So this is 3 to 5 is a suction volume, so that it will take this much volume of air and it will start expanding. So it will start expanding from 3 to 4. So 3 to 4 is the expansion process. So here you can see the volume is increased. At the same time, the maximum pressure is drastically reduced from P3 to P4. That's why it is expansion process. The pressure will be decreasing very much. So that is constant pressure expansion 3 to 4. Then the next process is in the cold chamber or refrigerator. So here in this process, it is going to absorb the heat in a constant pressure process. So 4 to 1 is again constant pressure process. Here the actual refrigerating effect takes place. So by absorbing the heat of those food items or whatever is kept in this refrigerator, by absorbing the heat from those things, it is going to absorb the heat in a constant pressure, maintaining constant pressure. So that's why it's a constant pressure heat absorption process. So this way the entire cycle is represented here. 1 to 2 is isentropic compression, 2 to 3 is constant pressure heat rejection, and 3 to 4 is isentropic expansion. Again here 3 to 5 to 3 is suction, then followed by the isentropic expansion. Then after that it is constant pressure heat absorption. So this is the complete cycle of Bell-Coleman cycle. So if you want to see separately also, here the compression process is represented in this the area enclosed in this particular diagram is the compression process. So 1 to 2 and this is the 2 to 5 and then 5 to 6 and 6 to 1. This is the compressor operation. So this is a reciprocating compression. So this is compression, then suction, then expansion, then compression, like that it is. So then this is the expander operation. As I told you, so this it sucks a small quantity of air, then that quantity of air is going to be expanded from 3 to 4. So that is why it is the expansion. So expansion process. So this is expander. So these are based on this Bell-Coleman cycle, there could be some problems in the examination. So typically at least one problem they are asking in the examination based on the Bell-Coleman cycle. So if you see the old question paper of May 2017 RNDC paper. So in this paper you can see there are some questions based on the Bell-Coleman cycle. So if you see the unit number 3, in the unit number 3 you have two questions coming from the Bell-Coleman cycle. So So first cycle is this 6b is also Bell-Conwan cycle based problem only, and 7b also is based on the Bell-Conwan cycle only. So we'll try to solve one of these problems so that we can complete this Bell-Conwan cycle. So for example, if you take this 7b problem, so a refrigerating system working on Bell-Conwan cycle receives air from cold chamber at minus 5 degrees centigrade. So that is minus 5 degrees centigrade, that is a cold chamber. That's where the refrigerating effect happening, and it compresses it from 1 bar to 4.5 bar. So then compression is happening. Then compressed air is then cooled to a temperature of 37 degrees centigrade. So the compressed air, it is cooled in the heat exchanger. So that is 37 degrees. Before it is expanded in the expander. So that means after this heat rejection, let's say expanded in the expander. So now they are asking us to calculate the COP of the system. COP of the system, that is coefficient of performance of the system, when the compression and expansion are, one is isentropic way. Suppose if the compression and expansion are happening in the isentropic manner, so then in that case we have to calculate COP. This is the first scenario. Second is same, we have to calculate COP by second option is follow the law of PV to the power of 1.25 is constant. In the second case they are asking is to assume this kind of process, that is PV to the power of 1.25 is called constant, means that is nothing but polytropic process for compression and expansion. So this is the problem. We have to find out the COP of the system. One, in the first case by assuming the compression and expansion in isentropic manner. In the second case by assuming the compression and expansion is following the polytropic process. So this is the given problem. So we'll try to solve this problem. So I have written down the same problem here. So in order to solve this problem, so the given information we can represent in the PV diagram. So the PV diagram is similar to this what we have discussed earlier. There is 1 to 2 compression, 2 to 3 constant pressure process, 3 to 4 expansion, and then 4 to 1 is the heat absorption. Again constant pressure heat absorption. So same thing we can represent on the TS diagram. So in the TS diagram, so obviously 1 to 2 is isentropic process, isentropic compression. So obviously, so మనకి ఇక్కడ